All right, so Qwen 3.8-Flash-Next has just dropped. I've been getting lots of alerts on my phone on this, and I've been noticing all the AI slot videos come out regarding its announcements. And I wanted to take a look here at the model card. So let me just share screen. This is the official Qwen model card. It looks like the model itself is fairly large, and it's using some new technology that we might have to deep dive. We just did a video yesterday about MTP modules and how they kind of operate. So it's kind of interesting that this kind of builds on that video. Anyways, the base configuration is massive, and this can be very difficult to run on local AI hardware. So I'm going to take a look at Unsloth's model card here to see the sizing, to see if it's something that even I can run on my unified memory rig. It looks like 4-bit quantization is looking at 111 gigabytes, and that is too big, at least for my current setup. 90 gigabytes for 3-bit, 78 and 74 for 1-bit. So fairly large model. Looks like there is an install guide here. Oh, I had it open, but let's just take a look here by Unsloth. It's new open weights, 125 billion parameter. So it is obviously larger than 27B. Mixture of experts, multimodal model by Qwen. Build on new Qwen 4 architecture. That's interesting. Supports 262K context window, advanced reasoning, and it's actually claiming to outperform Claude 4.6 Opus Max, which is awesome. Can run locally with 75 gigabytes or unified memory without no GPU VRAM required. So I'm curious to see what that entails. Is that the smallest quantization? Probably. Unsloth likes to do this, where they make these claims, and it's usually the smaller quantizations. So GGUF, desktop, 1-bit is 75 gigabytes. Yeah, so it is the 1-bit version. It uses 4 bits for the engram and PLE, and this is 79% smaller than BF16. Yeah, so that's what I was saying on the model card. The model card for Qwen 3.8-Flash-Next is 355 gigabytes, which is massive. It retains a top 1% accuracy of 80%. So I wonder if they have any benchmarks down below. Let's take a look. Usage on CPU, RAM, VRAM relative. Okay. Requirements, here we go. So the smaller quant works on 75 gigabytes of RAM. So best if you have 96 gigabytes of RAM or unified memory. That's crazy. So even at the 1 quant, it wants 96 gigabytes. That's a ton. Table hardware requirements equals units equals total memory, RAM plus VRAM, or unified memory. So at 1-bit, 75, 2-bit, 79, and then BF16 is 355. So nothing new there. It's pretty chunky. So I think maybe on my Halo Strix rig, I might be able to run this. Maybe a 2-bit. I'll have to do some benchmarking to test, and that's probably what I'll end up doing overnight. So subscribe if you want to see that. Obviously, we don't expect crazy improvements. This is a really large, massive parameters, 125B, but I believe that it doesn't have all that active at once. I believe there is like a split attention. Let me take a look here. Qwen 3.8-Flash-Next, a hybrid thinking model. Yep. Temperatures, thinking mode 1, 95, 20, pretty similar to 3.8, 27B. Instruct mode, context window, very similar. Thinking and preserve thinking. So same flags, we have the reasoning efforts. We kind of went through this in a previous video for 3.8, 27B. So it seems like similar configs. Here's the quantization analysis. So we ran KDL. And for those that don't know what KDL means, it's KL divergence. It's a way to measure essentially how much the quantization model, it's like the model's next token probabilities drift from the original full precision model. So essentially it looks at the next token and see how likely it's going to drift from the original BF16 model. Obviously the lower, the closer it is to the original. And Unsloth does it in their specific way. So this is not like a standard benchmark. This is kind of how Unsloth does it. So it looks like we have this on space gigabytes down here and the mean KDL. So as obviously the lower number the better. So we start off at a one quantization up here, and then we go down 2, 3, 4, and 4 extra large down here. So it's saying that at a Q1 in 72.5, the small version, the mean KDL is 0.3, which is obviously quite a bit worse than the Q4, which is at 0.04. Same top percent, we have 93% at a Q4, which is usually the sweet spot for these larger models. This is a really large model, so this is a very interesting sweet spot. And then at a Q1, you're looking at 80%. So there's obviously some degradation, and I'm guessing the next token is going to be off compared to a lossless format. So how to run this, here's Hugging Face, a model scope soon, execution, here's some instructions on how to do it on the desktop app, API, so yeah, here's the command to run it, connect it, setting it up on Llama CPP, and some benchmarks. I'm going to look at the benchmarks on the official model card by Qwen, so let's take a look here. I believe we're back here, see what it's comparing to. And sorry, it's just kind of me rambling. This is me, kind of my initial impressions and trying to figure out if I can even run this, honestly. I don't expect the speeds to be crazy fast because I'm in unified memory and my throughput is very low compared to a dedicated GPU or even like a Strix, like a DJX Spark or any of those kind of machines. So yeah, here's the benchmarks. Looks like parameters, we have 125, which is what we saw very similar on the Unsloth one, and then compared to Qwen's 27B, which obviously is 27B, and the active param is 6 bil. So it looks like the active parameters might cause some interesting. So it looks like the active parameters is significantly lower on this model. It's probably some of the technology behind it. Prediction head, QSA layers. Yeah, I didn't really, it's not really advertised in the model card name, but it looks like it is a 6 active model parameter model, which is great. A lot of luck from those in previous versions. So there'll have to be some deep dives on that, on how that works. I'll probably come up with another video once I figure out what this chart means, because this is kind of confusing to me. I just learned what MTP was in the last video, and prediction heads. This whole diagram is a different language to me right now. Anyways, back to the benchmarks. We have a Qwen 3.8-Flash-Next with 125B parameters, 6 billion active, with an n-gram embedding parameters of 51 billion. And I believe this is like pre-calculated token math that has to be done. Don't quote me on that. I need to read up on that. Score-wise, it compares against Qwen 3.8-27B, 3.7, DeepSeek Flash, and Claude Opus 4.6. Coding, agentic coding, so the Deep Suite 1.1, 58, which beats out Qwen 27B, expected. And then Opus didn't test on here. Agentic coding beats out Opus according to this. Suite benchmarks, multilingual, beats out Opus. And repo level management, looks like DeepSeek Flash wins on this one. Long horizon office work beats out Opus again. Professional task jobs, Frontier, and then I want to look at competitive coding on 91, which is crazy. So yeah, benchmarks, again, these are Qwen's own benchmarks. It obviously beats out 3.8-27B, which I would expect it to. It's a much larger model, even for its Q4 quantization, and even though it has less active parameters, the base model itself is massively larger. I'm very curious to see how it actually competes with Opus, if this is actually a 4.6 beat. So I'm sure that there'll be some additional benchmarks coming out. I'm going to check artificial intelligence site real quick to see if they have any benchmarks. I always call it artificial intelligence, but it's called artificial analysis. Let's take a look here if we have any details on Qwen. So I don't think they have any analytics as of this point, so I'm gonna have to follow up on this one. These are all just other ones. So yeah, I'm about to come back to that to see how it actually scores. I'm very curious. So yeah, it looks like I technically could run Q1. I don't know what the value of that is. I do want to see the tokens per second to see if it's any improvement from Qwen 3.8-27B, With MTP turned off at a level 2, I'm getting around 10 or so tokens per second, depending on the task. So I'm very curious to see how this works. And I'm curious about this technology as well, to see how this actually functions. And since it's only 6 billion active parameters, there might be some hope of it being faster, which might make it more usable. But at a 75 gigabyte, which is what Unsloth recommends, it's a tough sell. That will consume most of my unified memory, and with that buffer rate that they said that you need kind of 96 gigabytes of RAM, I have like 128, so I have a little bit of wiggle room. That's the OS, any desktop apps, things running in the background. Yeah, it's gonna be interesting. But yeah, initial impressions, cool. It came out. I will run benchmarks overnight, and I'll create a follow-up video tomorrow. So stay tuned for that. And if you are running, go ahead and put your comments on what your results are, especially if you're running on a unified memory rig. Very curious. Obviously, right off the bat, size-wise, 96 gigabytes is multiple GPUs, so it prices out a lot of people. Similar to kind of the DeepSeek Flash, right? It's not easy to run these larger models. I am having some initial thoughts about local AI and how these models, all as great as they are being released, it's very hard to be as excited because they're just getting they're getting harder and harder to run on local hardware. Like 96 gigabytes on unified memory is doable. There was just some announcement of the new Mac that's coming out with crazy high throughput unified memory. But to get 96 gigabytes, you're looking at a price of a car. So I'll do my test and I'll see what the tokens per second is. I'm very curious if it does improve. And if it does, you know, who knows, it might be a good news. But I haven't seen any videos of anyone testing it or running benchmarks on Halo Strix. So I will try to get those out as quickly as possible. All right, thanks for watching the video, and go ahead and subscribe and like the video and do all that stuff. Thanks for watching.